In the presentation Is It Worth Curating?, we focus on the phenomenon of modifications in using stone tools made from non-local raw materials. All the tools used to perform various activities were damaged. However, not every broken tool was discarded. For this reason, we would like to address the issue of a specific group of archaeological artifacts, repaired and recycled tools. We would like to take a closer look at the human behavior that is behind the prolonged use life of tools. The theoretical framework for our research was set by Louis Binford in the 70s, when the model of hunter-gatherer mobility organization was introduced. Binford formulated the concept of a curated technology addressing the relationship between tool use and discard. This concept was both eagerly used and criticized by many scholars. Criticism came from simplifications and ambiguities of the terms used in the concept of curated technologies. Although it is difficult to provide one definition, it is also worth mentioning the ideas presented by Bamford in the 80s. He noted that the concept of curation consists of at least 5 aspects of tool manufacturing and use. Curation is still considered as a complex behavior that is not easy to identify. In our research, we ask a question: how to recognize such a complex behavior? We started with the identification of traces observed on curated artifacts. Next, we analyzed them in the context of entire assemblages. Finally, we discussed the occurrence of curation among the Neolithic societies. The archaeological materials we choose are stone tools from 3 settlements of the first farmers in southwestern Poland. They are identified with the linear pottery culture, LBK in short. The sites Skoroszowice 1, Strzelin 16 and Strachów 2/2a are located in the largest concentration of Neolithic occupation north of Sudeten Mountains. They yielded a rich collection of objects made from a wide range of rock types. A dominant role as a raw material played metabazite from Mizerskie Hory, a part of the Bohemian Massif in today's Czech Republic. Metabazite was used for making ground stone tools with a cutting edge, commonly named hoes. They are called hoes, or adzes, or coulters because of the asymmetric convex flat cross and longitudinal sections. We distinguished 2 main types. The first type is high and long shoelast adzes, including smaller variants, sometimes called chisels. The second type is flat axes. This division is based on morphometric criteria only and is not supported by functional studies. This division is actually more problematic because apart from complete and fragmented tools, there are also modified objects which are beyond defined types. Most of them were classified as handstones, together with ball-shaped erratic pebbles, which did not require any preparatory processing. In the graphs, we present the percentage of particular groups of stone tools from 3 Neolithic sites. Tools with a cutting edge, made from non-local metabazite, occupy an important role in the assemblages, followed by handstones and grinding tools, including kernstones and grinding slabs, all made from local raw materials. Tools with cutting edge are also the most fragmented and transformed objects, so their life cycles were most complex than a biography of other types of tools. Tools with a sharp cutting edge, so those made from metabazite, were discarded at various stages of their life cycles. Apart from complete forms of adzes and axes, there are also broken tools with missing bad parts or cutting edges. Finally, there are repaired and modified tools, including resharpened axes and entirely modified adzes. What reasons stood behind the choices of tools modifications? Were some tools so important in some activities that they were kept in use at any effort? We applied two combined methods of study. Use were so microscopic observations and archaeological experiments. The experimental method was necessary to collect referential data of microtraces produced on metabazite-made tools. The use-were method was applied to identify traces of use and repair on both archaeological tools and replicas. The replicas were made and used mainly by the Czech team, supervised by Radomir Tichy. We recorded various types of macro and micro traces on the Neolithic adzes and axes. We classified them in terms of size and location. We have tools with working edges rounded and covered by tiny use retouch, with continuous grouped and separated microscars. Next, there are tools with large edge scars. And finally, we have broken specimens. Among this group of tools, we recorded 3 models of fractures: transverse one with an elongated macroscar, transverse one with small spin-offs, and transverse one with one side split off. The question is, what kind of activity produced such traces, and why did the tools break? LBK adzes and axes are considered to be used mainly for woodworking. Therefore, chopping and chiseling wood was the first activity we performed to produce traces of use. As referential data, we used metabazite-made tools manufactured and utilized by the Czech team. They successfully produced a dugout boat under a big project named Monoxylon Expedition. After we checked traces on the replicas, it was clear that working wood does not cause large edge alterations. Also, tools do not break during work. Working wood produces traces of small range, especially edge rounding, small scars, and tiny scratches. So, some tools, some of the Neolithic axes, were used for working wood. But if we would like to obtain broken tools, we need to perform other activities. We argue that fractures are so important in the tool life cycle because only broken adzes were modified. The transformation of the Neolithic tools included 2 main patterns. The first one included repairing the blunt edge without changing the tool function. Subsequent repairs just caused changes in the edge profile and edge angle in the archaeological objects. Traces of resharpening of a cutting edge display as long scratches parallel to a cutting edge or short, densely distributed lines oblique to the blade. They are similar to traces on the replicas, which must have been resharpened after a few hours of working wood. According to the second pattern of transformation, a fractured object was completely modified into another type of tool. After the modification, they looked like handstones because of 2 abraded poles. Owing to this, they are usually associated with kernstones and crop processing. Microscopic observations suggest that the function of so-called handstones modified from Schulast adzes was more complex. The first question we need to answer is how the poles were prepared. The surface is clearly more fresh than the ground surface of adzes, as well as bad parts of hafted unbroken axes, which are dark in color and polished. Experimental basalt knapping with basalt hammerstone produces a fresh surface, but it is also crushed. In the case of our tools, the surface of the poles is smooth and the edges are rounded. In addition, there are scars around the poles, whose proximal parts are wrapped by subsequent grinding. We performed experimental knapping of basalt and sandstone with metabazite-made hammerstone. These activities did not produce any scars around the poles, so it is clear that the poles of the archaeological specimens were intentionally flaked and carefully abraded before the secondary use. The second question concerns the function of new tools. Grinding cereals cannot be excluded. However, it is very difficult to distinguish between abrasive traces from preparatory processing and those from use. Microscopic observations of archaeological objects revealed concentrations of small pits. We conducted experiments including pecking and flaking sandstone slab. This activity was to initiate the preparation of Neolithic kernstone and obtain a rough working surface. The other experiment was knapping basalt to produce a tool. We have one such adze made from local basalt in Skoroszowice. Pecking produced discrete concentrations of pits. Flaking also produced pits, however, the scatters are larger and pits are distributed more densely. Our experiments showed that the use of curated modified tools as pecking stones or hammer stones is more likely than hand stones. It is possible that the idea of curation stone adzes, including function change, might have been generated as a part of LBK cultural package brought north of the Sudeten Mountains. It was not invented ad hoc when a tool was fractured. Only the high and middle variants of Schulast adzes were modified. They were made from non-local raw materials, almost exclusively used for manufacturing tools with cutting edge, whose production required time and know-how. Modification and secondary use of Schulast adzes included preparation of one or both ends by flaking and abrading, use as pecking stones or hammer stones, and secondary repair by subsequent abrading. What was the reason for curation? Why did the Neolithic people recycle fractured objects instead of using erratic pebbles easily accessible within the area they lived in? We can suggest several reasons behind such choices. Undoubtedly, the physical quality of metabauxite, its weight, for example, and morphometric features of primary tools, like shape and thickness, were important. The type of activities performed both with original adzes and secondary curated tools must have influenced this decision. Finally, the use of metabauxite as raw material enabled the LBK groups to stay in touch and increased bonds reflecting their cultural identity. The high value of metabauxite-made tools is evidenced by frequent finds from the Central European LBK context located at a great distance from the outcrops. Adzes were also grave gods, being important elements of funeral rites. They are also present in younger context. One of the examples is a hammerstone retrieved from a Neolithic settlement in Raczyce. Thank you very much for your attention.